When you turn this video off, please tell me the reason for it so that I can improve. Otherwise, hi and welcome. I'm trying to learn gastroenterology today, the digestive system, and after we've done that, we're gonna do lunge training. And if you participate in the lunge training, then it's at your own risk. And this is part 3 or 4 of the digestive system. And we're talking about internal anatomy, and this is no medical advice. Absorbing the products of digestion. The length of the small intestine, some 7 meters, is covered with seaweed-like fronds known as villi. Okay, the villi here at the top, which greatly increase the absorbing surface of the intestine. Sugars, amino acids, minerals, and vitamins in the intestinal contents are absorbed into blood capillaries in the villi, while fats diffuse into lymphatic channels known as lacterals. Okay, the intestine is first and foremost 7 meters long, and then has to increase the surface area, also these things it up, and then also with these little things, I think these are in the villi. And with these villi, in the villi, and the capillaries of the blood capillaries inside of the villi are absorbing the sugars, the amino acids, and the minerals and vitamins. And now fats are diffusing into lymphatic channels known as lacterals. They seem to be somewhere here in the middle. Now we don't really explain how it works, but there are basically 2 different types for it. Inside of these arms to the side, inside the intestine, there are the villi at the outside, and there are the capillaries in, and they are taking vitamins, minerals, sugars, and something. And the lacterals, things in the middle, they are taking the fats. Amino acids, sugars, amino acids, minerals, and vitamins. And the other ones are taking fats. Swaying and contracting movements of the villi caused by the muscular mucosae aid in the process of absorption. Okay, that whole thing is moving. The whole intestine is moving with this mucularis musculae, the muscle layer, and that makes them like seaweed moving, and they're having them even also these villi at them. And at these villi, or inside of them, there are blood capillaries, and with them they are absorbing sugar, amino acids, minerals, and vitamins. And inside of the whole big thing, there are also lacterals, and they are taking the fats. Molecules of digested food diffuse into the blood. Molecules of digested food diffuse into the blood and lymph systems via capillaries and lacterals. So the lymph system has a meaning. I don't really get what a lymph system is at all. But there seems to be already a different process with absorption of food out of the intestine. And also what kind of food. Let's read on. Here we have another thing. How food is digested. Within a few minutes of being swallowed, some of the food has been propelled into the first part of the intestine, which is called the duodenum, and the stomach is normally empty within 2 to 3 hours of a meal. Now, what is the stomach doing at all? I have an idea. The stomach is only there to add the gastrointestinal juices or whatever. There is not really anything happening. It is not the stomach doing. It makes even sense. The stomach is just this balloon. But the intestine, the small one, is 7 meters long. That makes totally sense. It is just there, waiting like in the drive-thru to be at its turn, and also while it's there, they're doing directly a car wash. Is there something like that? A drive-thru car wash? The average time taken for digestion to be completed in the small intestine, so we're talking about internal anatomy and other things, in the small intestine is approximately 12 hours. Okay. Within a few, I want to say at that point, the book is from the 70s, so maybe something more known. But what is written here is that within minutes, the first food is not in the stomach or well far into the stomach, but already in the intestine, in the duodenum, the first part of the intestine. It is no longer in the stomach after minutes. It is in the intestine. and after 2 to 3 hours, the stomach is empty. And that explains. So it means a human being could think that they already can eat again after 2 to 3 hours because the stomach is empty, but actually the whole intestine is still digesting. And they are only able to eat again because the stomach is empty. But they're still completely full in their digestion process. That could change something in the fundamental thinking about it. And then the average time taken for digestion to be completed in the small intestine is approximately 12 hours. And when in these 7 meters, 12 hours, but again, 12 hours, it could be that some people have 9 out of 15, I don't know, maybe more now. Food is propelled through the intestine by a regular series of muscular contraction or peristaltic wave, which squeezes the intestinal contents like toothpaste in a tube, so it's just pushed forward. And that movement is called peristaltic movement. How food is swallowed. Okay, we're having here a graph, we're having the pharynx, that is at the back of the mouth, the palate, is that the tongue? Okay, I don't know. No, when we're having the tongue. Then we're having the food bolus, and we're having the epiglottis, and the larynx, that is more down in the throat, and the hyoid bone. Okay, swallowing begins as a voluntary action, but at the back of the mouth, reflex action take over. Okay. I think that is actually interesting that they're pointing it out. So the human being eats and then swallows the food intentionally. But then, at the back of the mouth, a reflex and the whole automatic process begins. A small food ball, the bolus, is pressed against the palate. Okay, the food bolus is the food eaten, it's not part of the human body. The food bolus, the food ball, is pressed against the palate, which is at the top of the mouth, I think. Throat muscles hold the hyoid bone steady, and the epiglottis closes. The epiglottis must be the thing closing the air tract thing, the respiratory tract. The air thing where the air comes through. Over the larynx entrance to stop food entering the lungs. Okay. The epiglottis are closing, so that no food comes into the larynx part where it goes to the lungs. Food should not come into the lungs, but in the stomach. And they are both directly next to it. The thing with very important breathing, and the other thing where, when eating chunks of food, are coming down, and they should not go into the other one. Food is forced through the pharynx into the esophagus and then into the stomach. Okay, the swallowing problem. They are writing forced, and I think that is not a mistake or something. I think they actually mean, and if someone thinks about the swallowing process, the food is actually forced into the esophagus. Okay, next thing, gallbladder. A pear-shaped sac about 10... So we're talking about urination. A pear-shaped sac... No, we're not. I don't know the anatomy or completely English. A pear-shaped sac about 10 centimeters long, situated under the liver. It stores and concentrates bile secreted by the liver. After a meal, the bile is released into the duodenum to help with digestion of fats. Okay, there's the gall, it's below the liver, and the liver is giving its bile stuff, and the gall is now giving the bile stuff to the duodenum, to the beginning of the intestine after the stomach, so that the intestine or the duodenum can work with the bile from the gall, which is gotten from the liver. Small intestine, a coiled muscular tube, about 7 meters long, made up of the jejunum and ileum. Here digestion is continued and the resulting products are absorbed into bloodstream. Okay, we have it here in the beforehand. There are all these villi, and these villi with the capillaries, they are taking the minerals, the vitamins, and the minerals, and sugar, and vitamins and amino acids. And the lacteal inside of them, they're taking the fats inside the lymph system. Molecules of digested food diffuse into the blood and lymph systems via capillaries and laterals. Colon. One and a half meter. Long tube where water is absorbed to leave solid phases, consisting of indigested food remains, cells shed from intestinal lining, bile salts and acids from liver. The water is reabsorbed or absorbed. I think that is something which has to be pointed out. Water is again reabsorbed. And it makes totally sense. Already for the first idea, and I'm not going to talk about the second one right now. The first thing, and I'm going to talk about the second one. So the first thing, that it would be a totally waste of water for a human being and animal at all if the water would not be absorbed again. And the other thing, that could be something fundamental for medicine when we're talking about other problems with colon and other things. That one information here, that the colon is absorbing the water out of the feces. And on that we're ending. That was the digestion part. If you were here for digestion, you can go directly to the next part of whatever. That was not medical advice, that is the first thing. If you're for digestion, you're not right here, whatever. Now, if you were here for gastroenterology, you can go directly to the next part of gastroenterology, where we're going to read it all again in that part again. If you stay here and participate in the lunge training, then it's better to ask. One leg up and pull the leg up, point with the toes down, relax the leg. And the other leg up. Pull the leg up, toes down, and relax the leg. And now take the leg as the anchor, make a straight back, and point with the knee down to the ground. Other leg. Straight leg, straight back, and leg with the knee down to the ground. And now to the side. The torso pointing forward, stretching the inner side of the leg. Over to the other side. And now a few lunges in front. So first the right leg in front and back. Other leg, front, and back. Leg in front, back, and again. The leg in front and back. Now the static exercise. Down into 90-90 lunge, tall up with the back, and press from the side against the knee. And over to the other side. 90-90 lunge, tall up with the back, and press from the side against the knee. And over. 90-135 degree lunge, tall up with the back, and pull the leg up. And over. 90-145 degree lunge, tall up with the back, and pull the leg up. 150 degree lunge, tall up with the back, and pull at the top of the shin bone. Over again. 90-150 degree lunge, tall up with the back, and pull again at the top of the shin bone. Last exercise. Full lunge, tall up with the back, and pull at the top of the shin bone. And back. Other side. Full lunge, tall up with the back, and pull at the top. And now switching. With a garden gnome. One heel onto the ground, pull the toes in, and move the leg from left to right. Other leg with the heel onto the ground, pull the toes in, move the leg from left to right. Feet together, breathe in with the arms up. Come back, draw the shoulder blades together. In and up. Out and down. In and up. Out the arms, down, we're going down. Bend the right knee. And stretch your left one. Breathe in and change. Out and stretch. In into the middle. And out, come with a round back up. back with shoulder roll at the top. Legs wide apart, and we're closing with a trunk catalyst. Breathe in, arms up and out and down. In and up. Out and down. Breathe in and close the legs. And breathe in and out. That was my lunch training. I thank you very much, and until next time.